How we doing, guys? We're looking at text and test 4. Sorry, that should say page 26, 27. Question 19, 21 and 25. This is carry on from the previous video. Same exercise 1.6. The first question there says, write this fraction as the partial fractions a over x plus 1 plus b over x plus 4. So basically break up the denominator and write it as two separate fractions. But the way we're going to approach this is we're going to say, well, we need these two things to be equal. So let them equal and solve for a and b. So we're kind of working from right to left rather than left to right, as it were. If you wanted to work with this and put this together as one fraction, you'd need the common denominator, x plus 1 times x plus 4. So we're going to rewrite this as a times x plus 4 over x plus 1 times x plus 4 plus b times x plus 1 times x plus 1 times x plus 4. And now we can say that we have the same denominator, so we can put these together. We can say 1 over x plus 1 times x plus 4 needs to equal this whole thing over x plus 1 times x plus 4. So that's going to be ax plus 4a plus bx plus b. And well, because we have the same denominators here, we say the numerators must be equal. If we need these things to be equal, we need to get the numerators to be equal. So we need 1, which I'm going to write as 0x plus 1. We need that to be equal to a plus b x, that's these two terms here, plus 4a plus b. So what we get out of that is that a plus b has to equal 0, and that 4a plus b has to equal 1. So working on that, that gives us a is negative b. And then we come to this equation and we'll say, well, or that could also say b is negative a, is how I'm going to actually work with this. So instead of b, I'm going to say 4a plus negative a equals 1. That's 4a take a is 1, 3a is 1, and a is 1/3. And because we know that b is negative a, we can say b is negative 1/3. So the two fractions we need are 1/3 over x plus 1, which can be better written, multiply top and bottom by 3, and you get 1 over 3x plus 1. And the other one here is negative 1/3 over x plus 4. And again, multiplying top and bottom by 3, we'll get negative 1 over 3x plus 4. Okay, so these are the two fractions that they've asked us to write them as. A has to be 1/3, b has to be minus 1/3. Again, we're using that equating the terms in a polynomial that we've used in the previous video. Okay, question 19. Question 21 tells us, and again we're going to use this equating polynomials trick, but it tells us that x squared minus 2 is a factor of x cubed plus px plus q, and I've included a plus 0x squared term there just so that we have our polynomial laid out in x cubed, x squared, x to the 1, x to the 0 terms. This, if I square it out, is x squared, square the first, square the second is plus 4, twice the product is minus 4x. So if it's a factor, and this exercise probably by rights belongs later on with the factor theorem, but for what we're doing at the moment, it is kind of relevant as well. That's a quadratic and this is a cubic. So we must be multiplying this quadratic by some kind of linear term, okay, an x plus something to get a cubic. And that's something I'm going to say is capital A, and our job is to work out what A is. So we now actually have three unknowns, P, Q, and A. But because we know it's a factor, we can say that x squared by minus 4x by plus 4 multiplied by x plus capital A will give us x cubed plus 0x squared plus px plus q. And filling in the boxes here, we get x cubed minus 4x squared, 4x, ax squared, minus 4ax, and 4a. Okay, and straight away, the fact that the 0x squared term here comes from here. Okay, we can straight away say, well, the x squared terms are going to say ax squared minus 4x squared equals 0x squared, which is the same as saying a minus 4 is 0. A is 4, and that's kind of cracked it for us. We can come along now and say, well, if a is 4, 4a, which corresponds to q, is 16. Okay, so we say a is 4. If you like, you could remultiply this out again. I'm not going to, actually. I'm just going to say, let's do this kind of term by term. So the x squared terms gave us a is 4. 4x, take away 4ax, gave us px. Okay, these two terms. But we know now that a is 4, so that says 4x take away 16x equals px. Negative 12x is px, and negative 12 is p. And then 4 multiplied by, well, a is q, 4a is q, but a is 4, so that says 16 is q. And our polynomial to start with was x cubed plus, minus 12x for px plus 16. Now, last question, question 25. X squared minus kx plus 1 is a factor of ax cubed plus 0x squared plus bx plus c. Find the values of b and c and k. So this is the exact same type of question. This is a quadratic. It must have been multiplied by some linear factor to get a cubic answer. And what they want us to do here is show that, c squared equals a times a minus b. So if you have 25 open, that's what they've asked us to show. So that's what we're driving towards. Now, again, let's make up some factor. Well, actually, we don't even need to here. If we're a little bit clever, ax cubed came out of this box here. So this has to have been an ax here. And c came out of here. Well, 1 multiplied by c would have given c. And that lets us say, well, that's the second factor. So let's multiply this out and see what we get for a, b, and c. We get ax cubed, which is what we needed. We get minus akx squared. Sorry, that's a bit small. Here. And we get ax here. We get cx squared here. Minus kcx here. And we get c as expected here. So what do we get out of that? Well, ax cubed is ax cubed, no surprise. Cx squared take away akx squared equals 0. Cx squared take away akx squared is 0. Oh, that should have been 0x squared. X squared. Well, that tells us that c take away ak is 0, or that c equals ak. Okay, we'll come back to that in a minute. Ax take away kcx. So ax take away kcx equals b. X tells us that a take away kc equals b. And then finally c equals c. No surprises there. Now, we've been asked to show that c squared is a times a minus b. So what we're being asked to show has no k's in it. So let's get rid of our k. I can use this. I can say, well, k equals C divided by A. And I can sub that in up here. So I get A take away K, C equals B. And instead of K, I'm subbing in C over A. Now, what do we get there? A take away C squared over A equals B. Okay, we want to get a C squared, so let's tidy that up to get C squared by itself. Let's multiply let's move this to the right and this to the left. So we get A take away B equals C squared over A. Okay, just changing the signs, that becomes negative B on the left, that becomes positive C squared over A on the right. And then we want C squared, so let's get rid of this A by multiplying through, and we get A times A minus B equals C squared, which is what they asked us to show. So if this is true, then so is this. Now, can I ask you please, oh, I had no homework written out, sorry about that. Can I ask you now to do questions 17 and question 20. And in class tomorrow, we will do 18 and we will do 22 as far as 29. If we get that far, we'll do as many of them as we can. Okay, thank you.